Hi, this is Virgil Elkington, Lab 6, DC Circuits, Fall Quarter. This is my circuit for photo isolation. And to explain it real carefully, I've got it connected to the Arduino board. The heart of this circuit is this photoresistor, or this light resistor here. And the way that works is that I have it has a circuit that goes 5 volts coming from the Arduino board, and then it goes to the inputs to the isolator here, and then I have it as a resistor in series with it, but we have to go between it and get a split between there so that we can measure that. And that signal goes to the A0 of the Arduino board to get an analog signal. And that's really important for this circuit. We'll get back to that. So that circuit goes to ground from the resistor. And that resistor is a 5K ohm in series with the 5K ohm in series with that. And then the other circuit we have is a 9-volt battery fed into a 1,000 ohm resistor that goes into pin 5 of the relay. So pin number 2 of the relay is negative, and coming from pin number 8 of the Arduino board digital, that's the input into pin number 2 of the relay. Then we have a green LED, and a red LED. Now the purpose of the circuit is that when the photoresistor is tuned to being on and having least resistance on the on thing, and if it's shielded, or I put out the desk lamp is an LED, I don't know, 1,500 lumens. And when that gets dimmed or let out, the green LED will extinguish and the red one will come on. So we're going to be controlling with this photoresistor, this circuit, on how a 9-volt battery works. Now, what's important here is, I don't know if we can see this with the, but this is a delay of, I think, 250 milliseconds, and we're seeing that the on in this voltage divider is reading about, on the analog circuit, about 922. Now we'll see when we turn off the light how that'll drop down. It'll probably drop down to under 600, about 500. But in our code, we have written, if it drops down below, I forget, 600 or 500, then the relay action happens, and then pin 9 writes. So we'll take a look at that too. So we'll give it a quick shot here. So what's supposed to happen before we do it is I got the LED lamp on, desk lamp on. You can see that the green light is on. That's being fed from the 9-volt battery power. And then what'll happen is, when I put the light off, the amount of power in the voltage divider will show that not the voltage, but the input is under 600, and there we go. So there's the red light that went on. You can see that the lamp was off, and now if you look at the monitor screen, it's showing 583, 590. It's under 600 for the voltage divider input, analog input. Now, it was important when we were setting up this lab. I'll put the light on. We can watch it change. Look at it shoot back up to 920, and the green light is on. It was very important that when we were setting up this lab to get the analog input, we had to get a reading of the voltage divider between the 5K resistor and the photoresistor, so that we can do our if thing. And so we have it set if it's greater than 700. It's showing that there's no shielding of the resistor, and the light is shining directly onto it, which it is. There it is. There's that little bunker right there. It's getting the full glow from my desk lamp. But if it drops below 700, something's shielding. So here it goes. Let's just switch. Oh, I didn't turn it off. I just dimmed it a little bit. I'll turn it off all the way. Here it goes. You can hear the relay click. I don't know if you can hear that in the video. Now, there's another thing when we put on. Watch it go. It switches back to green. There's another thing we can do. If I just shield it a little bit, it'll switch also, because I'm not getting the full light that I programmed in it. So even with some shielding from the desk lamp, the resistance goes up enough so that the voltage divider reduces. And here it's like at 560 or something like that. And now it's back up over 700. So we have it. Now what's neat too, we could program this this light value for the split in the analog circuit higher or lower, so it's even more sensitive to whatever light is in there. So that's the end of this lab. Enjoy it. Thank you.